go ahead and see if this, yeah, okay, cool. So we are looking at the assignment from today. Today's February 18th. Very generically titled triangles, in particular dealing with, well, side lengths and angle measures. So triangles, this would be from section 10.2, part 1 is what the notes are titled. It's page, the problems I'm asking you to do, page 506 to 509. It's like 12 problems. Some are a little bit of a pain and some are not. 1 through 9 odd. 20. Shoot, that's not right. Take a couple triangles, cut out a couple triangles out of this little post-it note here if it stops sticking to me. Okay, so I love these little models, and so that's why I'm going to show you them. A piece of a sticky note, so partially stick for me. So, the first thought here is that 3 angles inside of a triangle. In fact, maybe I think I'll just do this one. I'll just skip the other one. We'll see. Either way, so 3 angles inside of a triangle always add up to 180 degrees. This particular fact is called the triangle sum theorem. Sum meaning you're adding, right? Triangle sum theorem. Triangle sum theorem refers to the fact that the sum of the 3 angles inside of a triangle always adds up to 180. Again, 3 angles inside a triangle always add up to 180. That is what triangle sum theorem is stating. That's what it states at least. So basically what we'd be saying here is, see, you have these angles 1, 2, and 3. If you add the measure of angle 1, then you don't have to write this down, plus the measure of angle 2, plus the measure of angle 3, it's 180 degrees. Okay, so can I ask one of you guys to chime in what other, maybe, shoot, what other thing do you know that has a sum total of 100? I'm telling you that the 3 angles inside of a triangle add up to 180 degrees, and I'm asking you, what other thing do we know, what other geometric figure do we know that has a sum or a 180 degrees of, total? What other geometric figure do we know, other than the fact that I'm telling you 3 angles inside of a triangle add up to 180? Name another geometric figure that's 180 degrees. Simple one. A simple sketch, that is. We'll do this, or a word. It's a straight blank, right? What other geometric figure do you know that has a total of 180 degrees? Will one of you chime in? Would be so kind as to chime in. What other geometric figure do you know that's 180 degrees, other than what I just said? 3 angles inside of a triangle add up to 180. No takers on that one? Am I confusing? What other geometric figure do you know that is 180 degrees? Okay, well, I'm getting crickets here. Well, I could chime in, but I thought one of you guys would chime in, right? So another geometric figure that I know that has 180 degrees is a straight line. Okay, I was just looking for a line here. I thought one of you guys would chime in and say a line. So, let me scoot that up a little bit. Okay, so there's my There's my straight line as you saw me construct with my straight edge. So basically this, if these three angles inside of a triangle, if three angles inside of a triangle always add up to 180, then a line is also 180 degrees. I can actually use this line to prove to you that these three angles do add up to 180. So it'll be like a physical modeling of the fact that the three angles in a triangle always add up to 180. So what I'm going to do is tear these angles off. It's a piece of paper, so I could tear off the angles. And then I'm going to put them right next to each other. Like, I guess I'm going to place them in an adjacent manner. And from that, you'll be able to see that three angles inside of a triangle. And just tearing them off here. There's angle 1, and 2, and I'm going to tear off angle 3. Right, so my triangle's not exactly a triangle anymore because I tore the angles off of it. And again, these three angles are supposed to add up to 180, so I'm going to place them. I'm going to place these three angles. Of course, the angle, the measurement would be shown by the point. The actual sharp corner is the angle size or measurement. I'm going to place them right next to each other. I'm going to place these angles so that they're adjacent. And in doing so, it will also basically prove to you that three angles inside of a triangle add up to 180 degrees. And I have to place them such that the angle measurement is what is being placed right next to each other. The size. And there is angle 3. Angle 3 doesn't have any sticky part, but either way, it may not be exactly perfect, but I'm trying to get it there, so anyhow, I do hope that you can see that by taking the three angles, and I can actually reconstruct this a little bit. This was a triangle, right? It had these angles. Right. Sorry, this is bad. This reconstruction is not good, but either way, it was a triangle, right? And I tore off the angles, right? I tore off angles 1, 2, and 3, and I was telling you guys that three angles inside of a triangle always add up to 180, but a straight line is always 180 degrees, so I used the three angles inside of a triangle to prove to you that they definitely add up to 180, and you can see that because they form that straight line. There's another construction that I was gonna show you, but I think I'm gonna skip it because I'm going to end up taking too much of your time with that and not enough time going over some of these problems. So kind of want to just get going on the assignment here. Number one. So I hope you guys have a sheet of paper out and will follow along, lest you have already started and you're ahead of me. I do hope you will get out a sheet of paper and follow along. Number 1 and number 3, those are my first couple problems. Number 1 and number 3 are, these are simply the most basic form of using triangle sum theorem. So let's see here. So I have triangle ABC, and I see angle C is 67 degrees, and I see angle B is 46 degrees, and hey, I know three angles in a triangle always add up to 180, guys, so I can add, right? I can add the measure of angle A plus the measure of angle B, which is 46, plus the measure of angle C, which is 67, and that always is going to add up to 180 if it's three angles inside of a triangle. So there's that. 46 plus 67 is a, whoops, this is a plus. Is 113, still equals 180, and then I can wrap it up by subtracting 113 both sides, and 180 minus 113 is going to leave me with 67 degrees as the measure of angle A. And so you can, if you did sketch it out, you can fill it in there. Notice how these are both 67. Two angles that are the same measurement would make it an isosceles triangle. And just a little tidbit of info: if it is isosceles, then it also has two congruent sides. The sides opposite those angles are congruent. And so you could take a look at number 3. I'll let you be on number 3. I'm going to plug ahead here. Probably skip number 5 also. And number 7. I'm going to skip 3, 5, and 7. I'm going to skip to number 9. And I'll skip to whatever problem you like if you ask. But for now, I'm skipping to number 9. Okay? I'll wait a moment, though, for you to look at least that number 3, and then if you have time you can look at 5 and 7, see if you have any questions. But number 9 will kind of, cover a lot of the ideas that show up in numbers 5 and 7. So in just a few seconds, guys, I'm going to plug along to number 9, and before I do, see if you can at least answer number 3. You may have to wait on 5 and 7. You might not have enough time, but again, as I'm giving you a moment here, I'm also going to remind you, encourage you to please follow along when we're doing the assignment together. It's easy points. All you have to do is copy, and then, hopefully you'll finish the rest on your own. Okay, number 9. Number 9 looks a little bit complicated. I'm gonna redraw that. Let's see. Yeah, I think it's mainly adding and subtracting, but then Pythagorean Theorem shows up, and that is a little bit of multiplying and a little bit of taking the square root. But yeah, it is, and some of it's just observing. A lot of it is just observing, right? So other than making an observation, yes, lots of adding and subtracting, and then Pythagorean Theorem, which I haven't really looked at with you yet. I think you've seen it before, but it doesn't matter. Like, you may have forgotten. So after I do number 9, I'm going to skip to number 21, which will allow me to chat at least briefly about Pythagorean Theorem. And I do hope that it ends up being, enough where you guys can kind of plug along on your own and possibly, bring me some questions tomorrow, or just ask me, whatever problems you want to see done. That'd be all good. So I'm going to plug ahead to number 9. Number 9. Kind of got to sketch it out, guys. It says lines L and M are parallel, so I'm going to start with those two lines that look parallel. Lines L and M. It says the lines of my paper actually help me do that. So it says lines L and M are parallel, and then there's a couple lines that pass through here, right? One of them passes through whatever angle. Oops, kind of messed that up, but either way. And the other one passes through kind of at the opposite angle, something like that. We have quite a few things here. Angle 1, angle 2, angle 3, 55 degrees here, angle 4, angle 5. Down here we have 120 degrees, angles 6, 7, and 8, and then 9 and 10. And I believe this one wants me to find the measure for each numbered angle. Most of them I can just observe as vertical or corresponding. So it does go back to stuff we've seen before, and then a little bit of whatever's here today. So I can start with the measure of angle 1, and I'll tell you, and you can decide if you have a question. It's 55 degrees because it is a vertical angle with this angle that's also 55. Vertical angles are always congruent, guys. So measure of angle 1's 55. Again, that's because I see it's vertical with the 55 degree angle. Don't forget these lines are parallel, so you have things like, let's see here. Angle 5 and 8 are corresponding. I actually don't have angle 5 yet, though. I'm going to get angle 5 next. Angle 5 is same side interior with 120, okay? So I'm going to just do a little mental math here. Once I observe these are same side interior, I know that they need to add up to 180, angle 5 and 120 degrees. So mental math, 120 plus blank is 180, right? Oh. I don't know if I'm ready for angle 2 yet. I'm reading your comment there, Joseph, and I'm like, well, would 2 be 65? I'm not sure yet. I haven't got there yet. So I would... Okay, that's fair, and I'll just add to that we can't just go by what it looks like, but the reason you're right is because they're corresponding. Like this whole measure that I'll kind of outline, this whole measure is corresponding with 120. So when you say they do look the same size, you're right, they are the same size. But technically they're corresponding angles, and this extra line cutting through makes that hard to see. But what you're saying is totally accurate. I didn't use that path, but you bring up a good point that the way you guys navigate through these angle measures is probably going to be different than the next person or myself. So we all can get all these angle measures in different ways and still get the same right answer. So I think you're right. Right? 155 plus 65, yeah, 120. That's definitely going to be 65. And it would be not just because they look alike, but the two parallel lines cut by a transversal would make them corresponding. So that's kind of what you kind of use corresponding angles without necessarily. Oh, there you go. Nice. So anyhow, yes, you can do that, and I guess I'll just continue on this other path also, guys. I was gonna say same side interior angles. These are 180. Same side interior angles add up to 180, so 120 plus 60 would be 180, right? So that one has to be 60. If you caught what Joseph said, he's right. Here's something else. 3 and 5 are vertical. Vertical angles are always equal, so if 5 is 60 degrees, so is 3. Again, vertical angles are always congruent. Now, what Joseph said is true, but also you can see you have a straight line here. So if you took a straight line being 180 and subtracted from 180, that's another way to get angles 2 and 4, because they're vertical, right? If you just subtract from 180, 55, and 60 from 180, you can get that. But that's not actually where I was going to go next. I was going to keep it as simple as I could without even calculating. Angle 6 is 120. How do I know? Vertical angles are always congruent. So 6 is 120. I'm trying to go through as many of these as I can without having to calculate. What else do I have here? Well, I do have this. I do have a straight line here, 120 degrees. Combine that with angle 8 and you have a straight line. And by the way, that's not the only straight line you can point out, but that's just one that I'm choosing. So 120 and 8 form a straight line, aka 180 degrees. So another option, instead of saying 180 minus 120 is 60 here, here's another option. Corresponding angles. Angles 5 and 8 are corresponding, and corresponding angles are always equal. Corresponding angles did come up just a second ago. So you can use corresponding angles again there and avoid any calculating, just observing. 7 and 8 are vertical, so 7 is 60 degrees. Right? Vertical angles are always going to be the same measurement. What else do we have here? Look, we have corresponding angles again. Angle 10 is corresponding with this 55-degree angle, so angle 10, 55 degrees. 10 and 9 are vertical, which means they're equal, so 9 is 55 degrees. The path that I'm taking to get these answers it's not the only way to get the answers, okay? And all I have left is angles 2 and 4. I did save that for last so I could use one different thing, right? I have a triangle in the center here. In the middle I have a triangle. Joseph, I'm not sure what you said you're bad about, but I think you're all good. So anyhow, guys, we have 3 angles inside of a triangle. And I know this, right? I know the three angles inside of a triangle, which for this one consist of angle 4 and 9 and 7, but I know those measurements, 55 and 60. So the measure of angle 4 plus 55 plus 60 has to add up to 180, because again, this is a triangle here in the middle, and the three angles inside of a triangle have to add up to 180. So if you add all that up, right, 115 subtract from 180, you would get to that. Oh wait, Joseph, I see what you're saying. I know what you said that about. Don't worry about it. Not a big deal. You're awesome for kind of thinking your way through it on your own. Anyhow, that's just what I did. At the end, I just left it so I could use the triangle sum theorem to get the fact that angle 4 is 65 degrees, and notice it is vertical with angle 2. Angle 2 you had brought up earlier, right? And yeah, 65. Either way, it's 65. So your method or waiting and using this, what I did, doesn't matter. It's still angles 2 and 4 are both 65. So I know that was quick, my friends, but there's a lot going on here, so we can't spend too much time on any one problem. I'm going to skip ahead to this Pythagorean Theorem stuff. Bear with me if you can. Number 21, that's where I'm going next, right? That's the next problem in our assignment anyways. Pythagorean Theorem's always, well, not always, but generally it's used for right triangles. It does have some application in triangles that aren't right triangles, but generally it's used for right triangles. So number 21, I have a side that's 8 meters and a side that's 15 meters, and I have a side that's unknown. It's just called C. So what I'm going to advise you guys is a right triangle is always composed of, the sides have special names. The sides that form the right angle, right, the sides that make or form the right angle are called legs. So those are my legs. The other side that is across from the right angle or opposite the right angle is called the hypotenuse. So again, first of all, the sides of a right triangle have these special words or names associated with them. The two sides that form the right angle are called legs, and the side that's across from the right angle or opposite the right angle is called the hypotenuse. And the hypotenuse is always the longest side. Here's what Pythagorean Theorem says, though. Pythagorean Theorem, according to A and B being legs and C being the hypotenuse, says that a squared plus b squared equals c squared. It's basically, you know, a leg squared plus the other leg squared equals the hypotenuse squared. The hypotenuse is always the longest side. It's always the one that has to go by itself. Adding the squares of the other two sides gives you the hypotenuse. So anyhow, right, hopefully that is something you can apply here. So for this one, leg squared plus leg squared equals hypotenuse squared is going to look like 8 squared plus 15 squared equals c squared. When you guys set up the Pythagorean Theorem, you do end up squaring the numbers, and then you end up either adding or subtracting and taking the square root. So again, square the numbers. 8 squared is 64, 15 squared is 225, and then c squared. And I know I'm going to go over time here, so if you have to leave, we're good. But either way, right? So you square the numbers. In this case, I'm going to add an x. 225 plus 64 is 289. I see you're out of here, Yaseli. All good. You try your best to wrap this up. Anyone who's leaving, try your best to wrap this up. If you're staying, I'm going to do this and then one more. See you later, Maya. Thanks for showing up, all you guys who are checking out. If you can stay, cool. Anyhow, you finished by taking the square root here, guys. Use a calculator if needed. The square root of 289 is 17. So that missing side length, Nisi, thanks, you also, 17 meters, okay? I'm going to set up one more, guys. I'm going to skip 23 because it's almost identical to 21. I'm going to skip ahead to 25, and then I'll call it good. So 25 is giving me, the unknown is a leg, so you actually have to set up 25 like this. A squared plus 16 squared equals 20 squared. I'm going to go ahead and finish this problem just in case anyone is using it. Square the numbers. Remember, it's always leg squared plus leg squared equals hypotenuse squared, so you have to set it up in a somewhat particular way. 16 squared is 256. 20 squared is 400. I'm going to subtract 256 on both sides to eventually solve this. That's going to leave me with 144. And now I'm going to take the square root to find that that missing side length is 12 centimeters in this problem. Okay, so I know we're out of time. I know I'm a minute over, so I'm going to let it be. But you guys try your best to get this done. Bring me questions tomorrow. Okay, have a good day. Thanks for staying. You guys have stayed. Thanks, Joseph, you too. And you guys all have a good day.